Hey everybody, it's Mr. Szabo. Wanted to put together a quick video here on writing our function rules, filling in our tables, doing our graphic representation, and then understanding domain and range, just so you had something to look back on. So this is the second problem from our notes on day 6. A car travels down an empty road at 65 miles per hour. If it already has traveled 16 miles, how far will it travel as each hour passes? So in this case, our function rule, we can see even in here what our input and output is. Don't forget that you always have that option. Our output is total distance or distance. Our input is actually in the table it says distance. Well, that's a typo, so we're going to fix that right away. That's the number of hours. And so we're talking about the distance versus the number of hours. I'm going to define my variables then. I'm going to call x the number of hours, then my distance I'm going to call d of x. So my function rule, writing this function rule, the distance as a function of the number of hours will be equal to, if we think about what this looks like, what the problem is saying is that our car is here already 16 miles past its starting point. So we're starting the problem here. From here, it's traveling 65 miles per hour. That's my multiplication of my number of hours. So I've already started 16 miles away. So this is 16 plus 65x. There's my function rule where x is the number of hours, and I can define that here. Number of hours. And d of x is equal to the distance, or total distance. And then we use that function rule to complete our table here. If I've gone for 0 hours, I find d of 0, and that's at 16. If I go drive for 1 hour, I find d of 1, and that's 16 plus 65 times 1. And then d of 2, 16 plus 65 times 2 is 146 miles, and d of 3 is 16 plus 65 times 3, and that's 211 miles. I've now got my function rule, that's my algebraic representation. I've got my table, that's my numeric representation, and now I can fill in my chart or my graph for my graphic representation. Number of hours, that's the input, it goes on the x-axis. I need to get from 0 to 1 to 2 to 3. Space those out equally. We're going to always have 0, 0 at the origin here. We're looking at quadrant 1 because we can't have negative hours and can't have a negative distance. So just to space these out equally, it's going to be easier for me to do 4 at the end. And I'm going to go halfway in between and put my 2, halfway in between put my 1, halfway in between put my 3. Equally spaced out, scale factor of 1. I needed to get to 3, I get to 4, so that's good. Here, I need to get to 211. So I need to go from 0 to 211. Well, 211 is a hard number to put on there, so I might go by a different number. I might choose something like 220. Something along those lines where I can know that I'm getting as high as I need. I might even go a little easier and try to go 250, and then see if I can count by 50s to get there. So if I know I can divide this 5 equally spaced segments, and it's not perfect, but it's close enough, where there's my 50, 100, 150, and 200. I've gotten at least to 211. The last thing I do is plot each one of these ordered pairs. 0, 16. There's my 0 for my x. That's 20, or that's 50. 25 is halfway, so it's less than halfway up. 181. 1, that's 100. I gotta go down a little bit. 2 and 46, or 146, so it's not quite to 150, just below it. 3 and 211, and I can go all the way up to 200 and just above that. And there's my graphic representation. The second part of these problems is asking us to determine if a point is realistic? By first describing what the point means. So remembering that this is my x coordinate, this is my d of x coordinate, or my y coordinate. That is the number of hours, that's the distance. So what the point means is that in 2.5 hours, that's what the x coordinate represents, we have driven 178.5 total miles. Okay. Is that realistic? Well, it's a two-part question. First, is x a part of the domain? Does that value represent something that's possible given the situation? Is it possible to drive for 2.5 hours? Of course it is. You can drive for 2.5 hours. So that is realistic, but that's only part of our issue. The second part is, if I have or do drive for 2.5 hours, have I driven 178.5 miles? So that's where you do have to check your function rule. I have to check that d of 2.5 is actually equal to 178.5. So I get 16 plus 65 times 2.5. And in fact I do, therefore it is realistic. It's realistic to drive for 2.5 hours, and that input would result in this output. So we'd want to state that in a sentence. So there we have it. You have your work, and then you have your sentence. It is realistic because you can drive 2.5 hours, and that would result in a distance of 178.5 miles. Go ahead and press pause and try number 9. Great, hopefully we got this answer here. Yes, it's realistic, or no, it's not realistic, because you cannot drive negative 2.5 or negative 2 hours. So you don't even have to check if it works in your function rule if that domain or your input is not realistic. So the whole point of doing those types of questions is to answer this. That has helped us start to think about our domain and range. Negative 2 didn't work, so we can't have negative numbers. Okay? Anytime we see something like all integers or all real numbers, that's including negative numbers and positive numbers, both of these. Since we can't have negative numbers, we already discussed that in number 9, it's not either A or C. And when it says all integers greater than or equal to 0, that is your positive numbers but not negative, so that's okay. This is also positive but not negative. The difference between integers and real numbers, this has no decimal or fractions. I'll just say no decimal. This includes decimals. Well, we talked about that already as well. 2.5 worked. That's not an integer. It's a real number though. So that's my domain. So I like to think of answering that question as this over here. To use this question to help me answer this question here. I know that my domain, some numbers are 0. I can drive for 0 hours. All of these decimals in between, and I can drive for 1 hour. All the decimals in between, I could drive for 2 hours. Well, if I mapped that to my range or my output, okay, if I drive for 0 hours, I plug that into my function rule, I'm going to get 16 because I've already started 16 out. Okay? And if I drive for 1 hour and I plug that into my function rule, then I'm at 81 miles. If I drive for 2 hours, I'm at the 146 miles. That's up there. And so on. I could keep going, but because I have all of these decimals here, I have all of the numbers in between here. So I can't look at this and just go straight to something like this or something like this, because this would neglect the fact that I can input something less than 1 hour or something between 1 and 2 hours. I have to state that it's all real numbers, but it has to be greater than or equal to 16. Because I can't drive negative hours, my range will never be less than 16. The answer here is D for my range.